Once again, welcome back students to our maths class of class 7, and in yesterday's video we have seen exercise 6.4 up to question number 3. So today we are going to see exercise 6.4 question number 4, 5 and 6. Question number 4 and 5, they are of somewhat same kind. The same diagram you have to use. One quadrilateral is given. So the name is given A, B, C, D, and the diagonals are given. And ABCD is a quadrilateral given, and we have to show is they have asked. Is AB plus BC plus CD plus DA greater than AC plus BD. So this is what they have asked. So is the sum of all the four sides greater than the sum of the two diagonals? Now to proceed for this particular sum, we will have to consider four triangles that we can see in the quadrilateral. The first triangle that we see is triangle A, B and C. This is the first triangle that we see. So first of all, we will start writing down in triangle A, B, C. So this is the triangle A, B, C. Okay. Again, this is a triangle, so the sum of two sides will be greater than the third side. So what we will do, we will keep the diagonals at one side and we will take the sides at one hand side. So first of all, in triangle ABC, by side sum property of triangle. Okay, so the sum of any two sides. So we will take the outside, that is the sides of the quadrilateral. AB plus BC will be greater than AC. Okay, AB plus BC will be greater than AC. Again, we will give this as number 1. Now, in triangle, this one triangle we have seen, another triangle BCD. In triangle BCD, again by side sum property. So instead of writing for each and every step, we can write down this at the top, by side sum property in triangle ABC. Now in triangle BCD, BC plus CD, BC plus CD is greater than, so BCD. So this is the diagonal, so it would be BD, and we give this as 2 number. So second triangle we have done. Now in triangle CDA, third triangle, in triangle CDA. So this is the first equation, this is the second equation in triangle CDA. Okay, CD plus DA, CD plus DA will be greater than AC. So this is the third equation, and in triangle DAB, only one triangle is there. So total 4 triangles are there. 1, 2, 3 and 4 triangles. In triangle DAB. So DA plus AB. DA plus AB should be greater than BD. And this will give as number 4. Again, now we are trying to prove the whole thing for the whole quadrilateral. Since these are the 4 equations of the triangles that are making this quadrilateral, so we will add up. Like in the third question, we add up all the 2 equations, 1 and 2 we added up. So here we are going to add 1, 2, 3 and 4. So that I will write here. I will rub out this also. Now add 1, 2, 3, 4. So again the same thing. What is on the left hand side, that will keep on the left hand side, and what is on the right hand side, that will keep on the right hand side. So first here AB plus BC plus BC plus CD, BC plus CD plus CD plus DA plus DA plus AB is greater than. The greater than sign is same for everyone, everywhere. So if you add up all these things, so it will be greater than addition of this. AC plus BD plus AC plus BD. So this much we have written now. We have added up all the 4. Now here we can see that BC and BC is common, CD and CD is common, DA and DA is common, AB and AB is common. Here also we can see AC and AC, BA, so here it should be BD. And here also BD. So all these are common terms. So we will recollect them together, we will gather them together. So here next step would be AB plus AB plus BC plus BC plus CD plus CD plus DA plus DA will be greater than AC plus AC plus BD plus BD. Up till here we have done. Now AB plus AB, 1 plus 1, that will be 2 AB plus BC plus BC, 2 BC plus CD plus CD, 2 CD plus DA plus DA, 2 DA is greater than, again here 2 AC plus 2 BD. In the question they have asked, is AB plus BC plus CD plus DA greater than AC plus BD? Now the only thing that it is here is 2 is a common factor to all the terms. So what we will do? We will divide by 2 to all terms. That means each and every term is divided by 2. So here divided by 2, suppose we divide by 2, 2 and 2 gets cancelled. Here divided by 2, 2 and 2 gets cancelled. So everywhere 2 and 2 will get cancelled and we will be left only with AB plus BC plus CD plus DA greater than AC plus BD. Hence, what was given in the book, we have proved. Hence, proved and done. Fifth sum is also of the same kind, but a small adjustment we have to do. Let us see what adjustment we have to do. Question 5, same figure is there, but to prove is a different thing. Again, AB plus BC plus CD plus DA is greater than twice AC plus BD. Now how to prove this? Okay, we have to show this. They have asked. This does not mean that we cannot show, but we have to show it. Since they have asked that means there must be some way that we can show this. So in the question number 4, directly we have taken 4 triangles, the 4 bigger triangles here. Now what we will do, we will give a point O where the 2 diagonals are intersecting. We will give here point O. Now we will consider 4 smaller triangles. Okay, OAB, OBC, OCD, ODA. So now 4 smaller triangles are there. So this is what a small adjustment we have done. Now first of all, only we will write down by side sum property of a triangle. That means everywhere we don't need to write. First of all, we have written down our property, that which property we are going to use. Now first, in triangle OAB, in triangle OAB, okay. So what we will do, we will first take these 2 sides, OA and OB. OA plus OB is greater than AB. Again, one number. In triangle OBC, OB plus OC is greater than BC. This is number 2. In triangle OCD, OC plus OD is greater than CD. This would be number 3. In triangle ODA, OD plus OA is greater than DA. So this would be number 4. Again the same procedure. Add one, 2, 3, 4. Add 1, 2, 3, 4. So when we add this, what we will get? Okay. This side, left hand side, OA plus OB plus OB plus OC plus OC plus OD plus OD plus OA is greater than AB plus BC plus CD plus DA. AB plus BC plus CD plus DA. Okay, now we have written our equations, addition. So I will report this now. Okay, I have kept the figure here so that afterwards there are some things that we have to show here. Now here we can see OA, AB, OB, OB, OC, OD, like this we are seeing. One of our side we have got AB plus BC plus CD plus DA, that is the LHS. Here it is RHS, but in the question it is LHS. So one of the side we have got. This we have not got. RHS we haven't got about from the question. So in RHS side we have AC and BD. Here we cannot see AC and BD, so we have to show it where how come AC is there, how come BD is there. So what we will do? Again we will recollect OA, OA, OB, OB, OC, OC, OD, OD. So OA plus OA plus OB plus OB okay, let us move like that only. OA plus OB plus OB plus OC plus OC plus OD plus OD is greater than AB plus BC plus CD plus DA. Let me correct myself. When I was reading the question, I mentioned that this is greater than twice AB plus AC. But that is not the case. This is less than twice AC plus BD. So here AB plus BC plus CD plus DA. It is less than. So here it is less than. Now OA plus OA will become 2OA plus 2OB plus 2OC plus 2OD greater than AB plus BC plus CD plus DA. Now here we can take out 2 as common factor. 2 in the bracket OA plus OB plus OC plus OD greater than AB plus BC plus CD plus DA. Again, here we are going to do some rearrangement. Now see here, what is meant by AC? OA plus OC, this both together makes it AC. So where is OA? Here is OA, here is OC. What is BD? OB plus OD, this total makes BD. OB plus OD, this total makes BD. OA plus OC, this total makes AC. So OA and OC will take common 2. OA plus OC plus OB plus OD is greater than AB plus BC plus CD plus DA. Now OA plus OC, this much, but OA plus OC equals to AC and OB plus OD equals to BD. Therefore, twice OA plus OC we can write down AC plus BD is greater than AB plus BC plus CD plus DA. Actually we have proved what we have to prove, but in the question this is LHS and this is RHS. So again we are just going to write it down in a proper way. So now I will rub out the question figure. Now see here, AB plus BC plus CD plus DA is less than. So AB plus BC plus CD plus DA is less than twice, this side is greater, twice AC plus BD, and this is what the question asks. Hence proved. So we have proved both the things. Okay. Okay, the last sum of exercise 6.4, that is question number 6. what the question says. The lengths of two sides of a triangle are 12 centimeter and 15 centimeter. Between what two measures should the length of the third side fall? So there is one triangle. You don't have to draw the question figure. This is only for your understanding. One of the side is 12 centimeter, another side is 15 centimeter. And what should be the length of the third side? Exactly, we cannot give the length. It can be anything from one range to another range. That is what they have asked. Between what two measures? Between what two measures the length of the third side should fall? So, given lengths of two sides of a triangle are 15 centimeter and 12 centimeter respectively. Okay. Now the third side we have to find between which two measures it should come. Third side is not known, so if anything is unknown, let the third side be x. So what we will do, we will consider this side to be x. Now let the third side be x. Since this is the triangle, the side sum property is applicable for this also. By side sum property of triangle, the length of the two sides is greater than the third side. So 12 plus 15 should be greater than x, that is the third side. So 12 plus 15, it becomes 27 is greater than x. 27 is greater than x means x is less than 27. X is less than 27. So we will give this as number 1. Okay, this is the first thing, A thing. Now B thing, 15 plus x. 15 plus x should be greater than 12. Transpose 15 to that hand side. X should be greater than 12 minus 15. Therefore, x should be greater than minus 3. But minus 3 we cannot have a measure. On scale we can take minus 3 as measurement. So what we will do? But length cannot be negative. Length cannot be negative. Therefore, x is greater than 3. So straight away, length cannot be negative. So we disconsider the negative sign and we take it as positive 3. Next. So give this as 2 number. Now next is 12 plus x. See, 12 plus x should be greater than 15. So transpose 12 to that hand side. X should be greater than 15 minus 12. So x should be greater than 3. So here we have the third option, third equation. If you compare all the 3 equations, comparing 1, 2, 3, we are comparing. So here we got x should be less than 27, and here we got that x should be greater than 3. So we come to a conclusion that x should be greater than 3 and x should be less than 27. So on comparing 1, 2 and 3, what we get? X should be greater than 3 but x should be less than 27. Therefore, the length of third side should lie between 3 and 27 centimeter. So it can be anything 4, 5, 6, 7, 8, 9 up to 26. Since it is between, that means we will not consider 3 and 27. So it should lie between 3 and 27. It can be 4, 5, 6, 10 up to 26. So this was the last sum of 6.4. Thank you.